Hello and welcome to the new set of the chapter 2 that we are talking about the elements of group theory. Now this is a sudden transition from symmetry element operations and molecular point group. We are heading towards a new topic that is quite mathematical in itself, but the essential components are very important for us to know about. So therefore we have started with the elements of group theory. In mathematics and abstract algebra, group theory studies the algebraic structure that are known as groups. It is applied to certain elements of a set and therefore it is closely related to representation theory and finds its applications in physics, chemistry and material science. You know what? The Rubik cube that was discovered in 1974, group theory has been used as an illustration of permutation groups which was invented in 74 by Arno Rubik. So that's the importance of the group theory in general. We'd like to define certain properties of a group. A set is given a designation of a group provided it satisfies certain rules. A group is a collection of elements that are interrelated according to certain rules that can be defined otherwise also. It has four basic postulates. If a set happens to define all the postulates, happens to satisfy all the four postulates, then that particular set would be designated as a group. So what are those 4 points? Let us discuss them one by one. Point number 1 that states that the product of any two elements in the group and the square of each element must be an element in the group. What does it mean? It means that if there are any two elements like E into A, so the product of E into A is equal to A, or if A dot B is equal to C, then all these components A, B, C and E should belong to the set that we are talking about, and it should be true for every element within the set. So the first point would be satisfied if the product or the square of any element should be a member of the set itself. You must notice that if any two elements of the set also commute, then the group is known as abelian group. And in mathematics, we say commutative law means if A dot B is equal to B dot A and the answer is C, and all A, B, C must belong to the given set A. So abelian group is the group in which any two elements also commute. Point number 2. It states that one element in the group must commute with all others and leave them unchanged. It means that if A is multiplied with something, so the answer is A, then we have defined that E is that element which does not alter the magnitude of A, and therefore E is designated as an identity element. Just like in mathematics, if you multiply by any number with 1, you get the same number. Similarly, E is the identity element here. What should be multiplied by with B? So that answer is B, that is identity E, and so on. And it should be noted that all these elements should belong to the set. In other words, identity element must exist for every element of the set. This was point number 2. Now proceed to point number 3. What does it state? It states that the associative law of multiplication must hold, and if you consider any three elements of set A, for example A, B, C are the elements, then this equality A dot B dot C should be equal to A dot B dot C, and the result should be same irrespective of the manner in which they are multiplied. So if the result A dot B dot C or AB dot C, or A dot BC or AB dot C, if it gives the same thing and the A, B and C all belongs to the same set, then I would say that associated law is correct in this sense. The next point, and that is the fourth point and the utmost important point of the group theory, is the existence of a reciprocal element within the set. And it states that every element must have a reciprocal, which is also an element of the group. It implies that what should be multiplied by A so that we get identity. So reciprocal of A, that is 1 by A or A inverse. Similarly, what should be multiplied by B, E, to get E, so that obviously when E is multiplied by E, the answer is E. E and E both are identity elements. And what should be multiplied by B so that we get E? So B should be multiplied by B inverse or 1 by B, then the answer would be E, and the A, B, E, A inverse, B inverse, etc. These elements should be the member of that particular set. So if this postulate is fulfilled, then we will see that this particular set can be given a status of a group. An example of this kind, A is equal to 1 minus 1, I minus I, can be taken for consideration. There are 4 elements, so order of the group is 4. Here I is known as a complex number, that's under root minus 1, it has the value. So if we start applying the rules, the first rule states that product or square. So if I say 1 into 1 is 1, so it's a square, and also the product of 1 itself gives 1. 1 multiplied by minus 1 gives minus 1. So minus 1 is within the set. Minus 1 when multiplied with minus 1, that result is plus 1, that is also in the set. I multiplied to I, that is I square, and I square would give minus 1, that is also in the set. So this way, if we keep on doing all the combinations, and if we find true for every situation, then I would say that each element of the member is each element that exists in the group itself. So the rule 1 is quite obeyed here. If I say the associative law and consider any 3 elements for association, say 1, minus 1 and I, the order in which we multiply, let us start from left to right. So 1 is 1, and in the bracket quantities you have minus 1, and other side the bracket quantity is also minus 1. So you have 1 into minus I on the left hand side, and minus I into 1 in the right hand side. So on both the sides there is minus I, and therefore I would say that the law, associative law, is correct in this case. Similarly, you can see another set of elements, identify yourself, and finally you will understand that both the left hand side and right hand side products are same, and therefore associative law is again true in this case also. Rule number 3, identity element must exist for every element. So naturally here 1 is the identity element. So multiply any number with 1, the answer remains unchanged. So it goes without saying that 1 must be an identity element for this particular set. A reciprocal element for every element must exist. So I would say what should be multiplied by 1 so that result is 1? Obviously it is 1 itself. So 1 is reciprocal to itself. What should be multiplied with minus 1? Obviously minus 1 should be multiplied by minus 1 itself. So you get 1. So minus 1 is reciprocal of itself. What should be multiplied with I so that you get 1? You get I into, if you multiply minus I, you get minus of I square, and that gives plus 1. And similarly, what should be multiplied to minus I? Obviously I. So in both the cases, answer would be 1. So the solution of every situation is actually a member of a group, and I would say that each element has a reciprocal that exists within the set. This way, we say that the elements of this particular set 1 minus 1, I and I minus I, they constitute a group. And this entire exercise can be explained in terms of what we call as group multiplication table. Let us have a look of that, and we'll study in details in the next video. So a group multiplication table is just a table where we have the entries of the elements in rows and columns, and on the termination point we write the point group or the status of that particular group. For example, if I say it's a group of order 4, I'd write G4 at that point. I'd write the entries on the column side, on the row side, and on the column side I will have the same entries. Now I have to depict the product. So the first line and the first row is going to be the same. Why? Because they are the multiplication. 1 into 1 is 1, so 1 into minus 1, so they are actually multiplying by 1. So the row and the column, first row and the first column, always remains same. Now keep on doing manipulations, mathematics. Say minus 1 into minus 1 becomes plus 1, I into minus I becomes minus I, and so on. So this way you will see that each element can be filled in this table. This is so called a group multiplication table, and interestingly you will notice that no 2 elements have been repeated in any row or column at all. So more about group multiplication table we'll have in the next video. Till then, thanks for watching and have a nice day.